Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is, for me, a brand new puzzle website that I found. Matthew Scroggs is the person's name, mscroggs.co.uk. He has a bunch of puzzles, and they look to be mathematics puzzles, but they're mathematics puzzles that you kind of need to solve using computers, at least as far as my understanding is, my limited understanding of pure mathematics in these regards. So I love these puzzles because I'm going to have fun trying to solve new things. I know I'm eventually going to get frustrated with them. I know this, but at least for day one, I got the answer. So let's take a look at that. So coming on here. So here's the website, mscroggs.co.uk. And I wish I could show you the page with everything. I just don't want to show you the answer just yet. But you can see that there seems to be a ton of puzzles for this, like, PhD thesis. Oh, good for him. But you can see puzzles, and over the course of years, I think it's just a blog. But I don't know too much about it. I'm just learning this guy's website, and I'm just learning today's problem. So today's problem looks like something like this. So let me just read it. Then have to watch me at 1/2 speed or 3/4 speed or whatever. The geometric mean of a set of numbers can be computed by multiplying together all the numbers, then computing the nth root. I don't know where did all the, something must have got lost in the translation here. And then computing the nth root of the result. There's an n of, there's something missing in here. But let's just look at the example problems, because that doesn't make much sense. The factors of 4, the numbers that evenly divide into 4, and for this problem, we're including 1 and the number itself. So 1, 2, and 4 evenly divide 4. So that if I multiply all of these things together, 1 times 2 times 4, I get 8. If I take the cube root of 8, I get 2. And if I take 6, yeah, there's symbols missing here. This is supposed to be the square root of 6. I know that much. And so the factors of 6 are 1, 2, 3, and 6. You multiply everything together, you get, I think, 36. Can I do this right? Yeah, 6 times 3 times 2, yep, 36. If I take the 1/4 of this, the inverse 4th root. Oh man, you can tell it has been a day for me. And what do you call that? The 4th root of this thing. So if you take the 4th root, you end up with square root of 6. And so forth here. And now the question is, the geometric mean of all the factors of the number you need to solve is 22. So if I do everything right, I get the answer of 22. And so here is the code. Not my proudest code, but it works. It's Python. And this is how I get the job done. So they told me that there is an answer where the answer comes out as 22. So if I didn't know this, if I was just trying to find values, I wouldn't write the code this way. But they told me there's an answer, so I can basically run a repeating while loop until I find the answer I'm looking for. That's the only reason I'm going for this today. So I go, okay, let's start with the number 1 and say, okay, what are the factors of 1? This code here basically gives me the factors and then multiplies it, like I said, multiplies everything out as we need to, and then keeps track of how many factors I found along the way. So for for value 1, for value 2, for value 300, it goes through and it figures out all the values that are divisible, multiplies them all together, and tells me how many there are. So when I get out of this for loop, I have that information. What is the value of multiplying all the factors together? That's going to be called value. And the number of factors itself is going to be that number. And as you see here, there have to be at least 1, because like for value 1, it's 1 and 1. But for value 6, there's at least 2, because it's 1 and 6. So there's always going to be at least 2 factors to worry about for any number greater than 1. So I'm fine. I don't have to worry so much about this being a divide by 0 error. So what I can do then is I can say, hey, value, whatever you are, take the root. How many factors? Take the factors, the nth root. If there are n numbers, n factors, then take the nth root. And that is just the same as powering to the 1 over the number of factors. So that's what this code is trying to say here. I'm basically powering to, to an inverse factor. And now this last code might be a little interesting to some of you guys, because let me run the code and you'll see you're never going to get an exact answer because of the way computer science, weight floating point numbers work. You know, every value that is not a power of 2 in some shape or form is essentially irrational and binary. And so for 64 bits, or however the number is represented in binary, you see that even though the answer truly is 22, the way I've computed everything, the answer isn't truly 22. It's very, 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 very close, but there's a small, very small, very, very small rounding error when we're getting to there. So that's what this code is basically saying. How different is the number that I get when I do the crazy math from actual 22? And if it's less than something to, what is it, 7 or 8 decimal places, then I know that the numbers are essentially equal. And that's where the answer comes out. 484 is the answer. All the factors of 484, when you multiply them together and take whatever root that is, that's the one thing I didn't check to see how many factors there are. Let's see. Let me do it. And I can say factor, and then let's run it again. I didn't anticipate that. I didn't even think about it. So there's 9 factors involved here. You multiply those 9 values together, and you get yourself whatever value. You take the 9th root of that number, and you get 22. So that's going to be a pretty large number. You know, what's 22 to the 9th power, right? Or is that how it goes? But anyway, so that is my answer. And then I break out of the loop because there's only one number that's going to be 22. So and then if I don't find the value as I'm going, because I had to go from all the way up to 484 to find it, I just keep incrementing my number. Hey, let's try 1, let's try 2, let's try 3, let's try 4. And again, at 484, that's where we find our end result. So that solves this problem. I'm looking forward to day 2. I hope they keep it relatively easy. We'll see as we go. Otherwise, I'll be learning a bunch of math, and hopefully I'll find solutions and be able to post this for those of you who are interested. So thanks as always for sticking out with me here. If you have any questions or concerns, or you know a better way to do this, please comment below or email me at swardb@cud.edu, and I'll get back to you as soon as I can. Thanks, everybody. Hope to see you tomorrow.